Welcome to another lesson of Math 1314, College Algebra. Today we will be discussing Section 2.2, Linear Equations in One Variable. In this section, we will solve equations in one variable algebraically, we will solve rational equations, we will find linear equations. If we're given the equation of two lines, we will determine whether their graphs are parallel or perpendicular, and we will write the equation of a line parallel or perpendicular to a given line. Let's jump right in. Let's start with some definitions. Feel free to pause the video if you need to write these down. First, a linear equation is an equation of a straight line which is written in one variable. The only power on the variable is 1. Linear equations in one variable may take the form ax plus b is equal to 0. Now, a linear equation can be one of three types. It can be an identity, it can be conditional, or it can be inconsistent. An identity equation is an equation that's true for all values of the variable. A conditional equation, on the other hand, is only true for some values of the variable. And then finally, an inconsistent equation is an equation that's not true for any values of the variable. It results in a false statement. Finally, the solution set is the set of all values that make a given equation true. Let's now move on and talk about how to solve a linear equation in one variable using algebra. So how do we solve a linear equation in one variable? Well, our first step is we can add, subtract, multiply, or divide an equation by a number or an expression, making sure to do the operations to both sides of the equal sign. We cannot divide by 0. So you can add, subtract, multiply, or divide an equation by a number or expression as long as it's not 0 and as long as you do the same operation to both sides of the equal sign. Then the second step is to apply the distributive property as needed. So A times the quantity B plus C is the same as A times B plus A times C. The next step is to isolate the variable on one side of the equation. So you want to get whatever variable you have on one side. And then when the variable is multiplied by a coefficient on the last stage, you can multiply both sides of the equation by the reciprocal of the coefficient. Let's try an example. Let's solve the equation in one variable, 2x plus 1 is equal to negative 9. Now this equation can be rewritten in the form ax plus b equal to 0 by subtracting or adding 9 to both sides. However, we can proceed and solve the equation in its original form by performing algebraic operations. The first thing that we want to do is we want to subtract 1 from both sides. That leaves us with 2x is equal to negative 10. Now we're in the last step where we have a coefficient in front of the variable, so we can multiply by the reciprocal or divide by that coefficient. So we divide both sides by 2. The 2's cancel, and we have x is equal to negative 10 over 2, not 10 over 10, 10 over 2, which is negative 5. So x equals negative 5 is our solution. Let's try a little more complicated example. Let's now solve this equation in one variable, which is negative 2 times the quantity 3x minus 1 plus x is equal to 14 minus x. Now the first thing we want to do here is we want to apply the distributive property. So negative 2 times 3x is negative 6x. Negative 2 times negative 1 is plus 2 plus x is equal to 14 minus x. Now we want to combine like terms. So negative 6x plus x is negative 5x plus 2 is equal to 14 minus x. Now we want to get all of the x's on one side, so we can add x to both sides. And negative 5 plus 1x is negative 4x plus 2 is equal to 14. Then we can subtract 2 from both sides to isolate the variable. So negative 4x is equal to 12. Now we can multiply by the reciprocal of the coefficient negative 4 or divide by negative 4 on both sides. The negative 4's cancel, and x is equal to 12 over negative 4, which is negative 3. So x equals negative 3 is our solution. Probably the most familiar and most used form of a linear equation is the slope-intercept form, which looks like y equals mx plus b, where m is slope and b is the y-intercept. So the first thing that we start with is the definition of slope of a line. The slope of a line, m, represents the change in y over the change in x, oftentimes called the rise over the run. If we have 2 points, x1, y1, and x2, y2, the following formula determines the slope of the line containing those 2 points. The slope, m, is equal to the difference in the y's, y2 minus y1, over the difference in the x's, x2 minus x1. Let's try an example where we take 2 points and find the slope of the line that goes through those 2 points. Let's find the slope of the line that passes through the points negative 2, 6, and 1, 4. Now, our slope formula is m equals y2 minus y1 all over x2 minus x1. Now, it does not matter which order we choose our points. Either one can be x2, y2, or x1, y1. In this case, I'm going to choose the first point as y2, x2, y2, and say 6 minus 4, our y values, over negative 2 minus 1. So 6 minus 4 is 2 over negative 2 minus 1, which is negative 3. So our slope, m, is equal to negative 2 over 3. So the slope of the line that passes through the points negative 2, 6, and 1, 4 has a slope of negative 2/3. Now, if we were given an equation in y-intercept form, slope-intercept form that is, can we determine the slope and the intercept? Let's try an example. In this case, we want to identify the slope and y-intercept of the equation y equals 3x plus 2. We can tell from it being in slope-intercept form that m is the slope, which is the coefficient in front of x, so m, the slope, is equal to 3, and the y-intercept is the plus b part, or in this case, 2. So our slope is 3, and our y-intercept is 2. Now you might also consider that as 3 over 1, which is the rise over the run. So for every 3 units you go up in y, you go over 1 unit in x. Let's now move on and discuss the point slope formula, which will help us determine the equation of a line given a point and the slope. The point slope formula. The point slope formula says that if we're given 1 point and the slope, that the point slope formula will lead to the equation of a line. So what we can do is we can say that y minus the y value of our point, y1, is equal to m, the slope of the line, times the quantity x minus x1, which is the x-coordinate of the point we're given. And then what that allows us to do is then plug that point in and the slope, and we can get the equation of the line that contains that point with that slope. We can solve that then for y to have it in slope-intercept form, so we can determine the y-intercept of the equation and graph it. Let's try an example where we're given a point and the slope and find the equation of that line. In this example, we're given that the slope of the line is m equal to 4, and we want to find the equation of the line in slope-intercept form, which is y equals mx plus b, that goes through the point 2, 5. So let's use the point slope formula. Remember, y minus y1 is equal to m times x minus x1. Let's plug in 2, 5 there. So y minus 5 is equal to m, which is 4, x minus x1, which is 2. We can now distribute the 4 to the x, which gives us y minus 5 is equal to 4x. 4 times negative 2 gives us minus 8. We can add 5 to both sides, and we get y is equal to 4x minus 8 plus 5 is minus 3. So our line in slope-intercept form is y equals 4x minus 3. Note that your slope, m, is 4, and your y-intercept is negative 3. Let's now do an example for finding the equation of a line if we're given 2 points. How would we do that? Okay, this time we want to find the equation of a line passing through the points 1, 2, and 2, 4. Now we know we want to use the point slope formula, but we have 2 points and no slope. So what we need to first do is find the slope using the slope formula, which is m equals y2 minus y1 over x2 minus x1. Well, in this case, that's 4 minus 2 all over 2 minus 1. Well, 4 minus 2 is 2, and 2 minus 1 is 1, so our slope is 2. So now we can choose either of those 2 points to plug into the point slope formula, which is y minus y1 is equal to m times x minus x1, and we'll use the first point. So y minus 2 is equal to 2 times x minus 1. We can distribute the 2 on the right-hand side. 2 times x is 2x. 2 times negative 1 is minus 2. So we have y minus 2 is equal to 2x minus 2. And then we can add 2 to both sides. So y is equal to 2x. The negative 2 plus 2 cancels out to be 0. So we have y is equal to 2x. Now what is our y-intercept here? Well, it's understood that if there is no y-intercept visible in the y equals mx plus b form, it's assumed that there's a plus 0 there, but we don't actually write that. So y equals 2x is our equation, and it goes through the point 0, 0, which is the y-intercept. In addition to the slope-intercept form of the equation of a line, another way to view the equation of a line is the standard form of the equation of a line. The standard form is written as ax plus by equal to c, where a, b, and c are integers. What this means is that we have the x and y terms on one side of the equal sign, and the constant term is on the other side. Let's try another example where we are given a point and a slope, and we want to write the equation in standard form. So for this example, we have a slope of negative 1/3 and a point 1 1/3. So we want to find the equation of the line in standard form with that slope through that point. So we'll use the point slope formula. So y minus 1/3 is equal to m, negative 1/3, times x minus 1. So what we can do is distribute. So y minus 1/3 is equal to negative 1/3 x plus 1/3. Okay, so we can add 1/3 to both sides to get y is equal to negative 1/3 x plus 2/3. Is that the end of the problem? Well, it would be if we were asked to put it in slope-intercept form, but in this case we're actually asked to put it in standard form. So let's add 1/3 x to both sides. So we get 1/3 x plus y is equal to 2/3. Now, is that in standard form? Not quite. This 1/3 can't be there because we need it to be an integer. 1/3 is not an integer. So the way we get rid of that denominator, or that fraction in this case, is we multiply both sides by the denominator, or the reciprocal of 1/3, which is 3. If it was 2/3, we would multiply by 3/2. So what we do is we multiply both sides by 3. Okay, need a pen, not a highlighter. And we need to multiply this side by 3 as well. So 3 times 1/3 x gives us just x. Again, it switched on me. 3 times y gives us 3y. And 3 times 2/3 gives us 2. So our equation is x plus 3y equals 2, and that's in standard form. Let's talk briefly about vertical and horizontal lines. The equation of a vertical line going up and down is given as x equals c, where c is constant. The slope of a vertical line is undefined. Why is it undefined? It's undefined because the difference in the x values is 0. And in our slope formula, that causes division by 0. So the slope is undefined. In a vertical line, no matter what the y value is, the x value is always constant, and it is equal to c. On the other hand, the equation of a horizontal line is given as y equals c, where c is constant. In this case, the slope is 0 because the difference in the y values is always the same, and it's 0. So no matter what x value we have, the y value is always equal to c. Let's try an example. In this example, we want to find the equation of the line passing through the points negative 5, 2 and 2, 2. So we can first start with trying to find the slope of that line. And we can say, take the difference in the y values, 2 minus 2, over 2 minus a negative 5. Well, 2 minus 2 is 0, and 2 minus a negative 5 is 2 plus 5, or 7. Well, 0 over anything is just 0, so our slope is 0. That means we have a horizontal line. And what is the equation of a horizontal line? It's given as y equals c, where c is some constant. What is the constant here? Well, our y value is always 2. So y equals 2 is the equation of this horizontal line. Let's now talk about parallel and perpendicular lines. Let's now go over the definitions of parallel and perpendicular lines. Two lines are said to be parallel if their slopes are equal and their y-intercepts are different. On the other hand, two lines with slopes m1 and m2 are said to be perpendicular and intersect at a 90-degree angle if m1 times m2 is equal to negative 1. In other words, their respective slopes are negative reciprocals of each other. So just simply, for example, if M1 is equal to 3/2, a perpendicular line M2 would have to have slope M2 equals -2/3. So you take a negative sign and flip it. So that's to have a perpendicular line. Parallel lines have the same slope. Let's try an example. So how do we write the equation of a line parallel or perpendicular to a given line? Well, the first thing we do is find the slope of the given line. Usually we'll do this in slope-intercept form. Then we use the slope and the given point for the second line using the point-slope formula. Now, if we are trying to find a parallel line, we'll use the same slope. If we're doing a perpendicular line, we'll need to have the negative reciprocal slope. So we'll flip it and add a negative sign to whatever it is. So after that, we will simplify the line to slope-intercept form and compare the two equations. Let's try an example. In this example, we want to find the equation of the line parallel to 5x is equal to 7 plus y and passing through -1, -2. We first want to find our slope of the first line. 5x is equal to 7 plus y. We can subtract 7 from both sides to get y is equal to 5. Try that again. 5x minus 7. So our slope is 5. And our other point for the second line is -1, -2. So we can plug that into the point-slope form. So y minus a -2 is equal to m, which is 5 times x minus a -1. So y plus 2 is equal to 5x plus 5. We can subtract 2 from both sides. We get y is equal to 5x. 5 minus 2 is plus 3. So the only difference between our original equation, which is y equals 5x minus 7, after we rearranged, and y equals 5x plus 3 is the y-intercept. 3 versus a -7. Now let's find a line perpendicular to a given line. This time we'll use the same equation and point, but this time we want to find the equation of the line perpendicular to 5x equals 7 plus y passing through -1, -2. So this time we'll solve again for y. We'll subtract 7 from both sides and get y is equal to 5x minus 7. That's our slope is 5. So our slope of our second line is the negative reciprocal, or -1/5. So we have plus 1/5 minus 2. And we can rewrite that in terms of fifths so we can have a common denominator. And so we would multiply it by 5/5, so -10/5. So our final answer is y is equal to -1/5 x plus 1 minus 10 is -9/5. So that's the line that is perpendicular to our original line that goes through the point -1, -2. That's the end of section 2.2. If you have any questions, be sure to email me. Good luck on your homework, and see you in the next one. Using point-slope formula, we can plug in the point, so y minus a negative 2 is equal to the slope of the second line, which is negative 1 over 5, x minus a negative 1. And we can distribute to get y plus 2 on the left side, negative 1/5 x plus 1 over 5. And then we can subtract 2 from both sides to get y is equal to negative 1/5 x. And then 1/5 minus 2